Our latest product, which is the GM703, the advantages on this is its step resolution. The machine has a 10 nanometer step resolution in X and Y, allowing us to do very fine surface finishes, very good control over the feature quality. And the other advantage is that it has a mandrel. The mandrel is our tool holder. That tool holder can actually be removed and replaced, made on a different machine to the shape that you need, or made on this machine. But it's really the integrity of that tool holder that allows us to have that precision. As other companies would have a chucking system where they would hold a wire and then they would have to trim that wire and move it back to the machine, they can't take it out, measure it, and put it back on. We can actually machine this, bring it to a microscope, measure it, bring it back, and use it in process. So our positional accuracy, once we remove that, is within a half a micron, whereas other collet methods are within 10 microns. So you can see the precision and accuracy of the whole system, not just the step resolution here, but also the mandrel system itself allows us to manufacture really with comfort these micro parts. The types of features that we can achieve, we can get down to sub 3 micron hole diameters. We can do an aspect ratio of maybe 5 to 1 on that type of hole diameter. When we get to 50 micron hole, which is pretty much standard for the micro industry, we can probably do a 20 to 25 to 1 aspect ratio. It allows us to give a very good surface finish. With the new Spark technology we've introduced, our surface finish is actually about 50 nanometers, R max, peak to valley. So it really allows us to have a very good surface quality, almost mirror finish with EDM only. And then the machine also can do micro grinding, micro milling, micro machining. With the micro grinding, which is a polycrystalline diamond tool now, which we of course shape on the machine as well to whatever diameter we'd like or feature, that now gets us to about 10 nanometer surface finish. So really mirror finish in a metallic material. And that allows us to now do micro molds, lens molds that have very good release properties, micro molding for medical device tooling. So it gives us a lot of range from the type of industries we can go to because of the surfaces and the integrity of the finish and the tool creation that we can have.
How does that work? How does it grind?
Sure. Well, the EDM obviously is we're using a tungsten wire in this case for EDM, and the EDM will be spark discharge. The fact that the abrasive, the polycrystalline diamond, what it is a diamond chip sintered into a metallic compound. The metallic compound, of course, having electrical properties, we can then shape that PCD material into whatever shape or size we need. So similar to shaping our EDM tungsten tool, we would shape our PCD. Now we can get that to, let's say, 10 micron diameter. So now we can bore actually physical contact with the polycrystalline diamond, where you have millions of diamond chips exposed in the material, could actually machine into a conductive or non-conductive. So we could do ceramics now, we could do glass, we could do a hard plastic, and we can now micro machine channels or holes in non-conductive materials as well. So the PCD, really the advantage is that we can shape the tool on the machine using electrical properties of the EDM as well as the tool conductivity. Once it's shaped, we turn the electricity off and just do a physical grinding with our 6,000 RPM spindle. And now we can do the same types of finishes or the same types of small features in non-conductive materials as well.
Yeah, there's a dramatic image on your website that shows concentric circles.
Yes.
Circles, yeah.
Yeah, those circles on the website, the largest diameter of that circle is 800 microns. The feature itself was only 10 microns deep and 10 microns at the top. It was basically a wedge-shaped tool that we used, and we just did a circular path and just had increasingly smaller circles to define that. And that was made in glass using the grinding.
Now, is that type of feature, would you find that on other products, other machines on the market?
Really, that feature was designed to show the three-dimensional control. Of course, that was only, as I would call it, 2D with height, because our tool did that taper, so we didn't have to do that. But really, it was to show the finesse of the machine's capability. The type of feature that you might see that on would be a microfluidic channel that needs to have a certain quality of linearity and then a certain pocket with a defined depth or defined feature, and then continue on so you can separate the different liquids in a microchannel. And this is where this type of technology would come in, is you no longer are limited by a macro tool bit of 50 or 60 or 100 microns, but you can get down to the 10 micron and create that feature of the depth of the pocket to what you need using the technology. And that's where something like that would apply directly into an industry.